Hello, in this short video we will be discussing how hand function is performed and talk about some techniques utilized to improve the quality of life of upper limb amputees. The hand plays a crucial role in performing many daily tasks, such as eating. Three primary mechanisms are involved in the performance of hand movements. The first mechanism is intent. Our brain conveys intent by instructing our muscles to move in a manner necessary to perform a given task. Motor function is the second mechanism and is our muscles' ability to manipulate our fingers to produce various hand postures. These postures determine our grasp and can be varied depending on the requirements of a given task. Sensory function is the last mechanism, and it allows us to receive information from sensory receptors located on our skin. This information describes a given interaction and can be used to adjust a movement based on this perception. When all three mechanisms are used in tandem, complex tasks can be performed. Unfortunately, when an individual undergoes an amputation, they lose their motor and sensory function, with intent becoming isolated. This often results in loss of an individual's independence. Some current prosthetic limbs can replicate the movement of the human hand and arm. In this video, the device matches the individual using sensors that record the user's joint angle. Although motor function can be restored, the device remains isolated from the amputee's intent and remains unable to provide sensory feedback. A common technique for identifying a user's intent is electromyography, or EMG. Nerve cells known as motor neurons control a muscle by transmitting electrical signals that cause muscles to contract. EMG records these signals using sensors placed on the muscle. Flexor muscles are used to close the hand, while extensor muscles open the hand. By recording the EMG from these two muscle groups and processing the signal, motor commands describing the user's intent can be sent to drive a prosthetic hand. In this video, it shows that by using EMG recorded from these two muscle groups, a prosthesis can match a user's hand movement, connecting the motor function to an individual's intent. Sensory feedback in this case is still absent, limiting user confidence and the ability to perform fine motions. In our lab, we use electrodes placed on the upper arm to electrically stimulate the median and ulnar nerve in order to provide sensory feedback. These nerves are responsible for transmitting information from the hand back to the brain, as shown in the diagram on the right. By stimulating these nerves, signals are sent back to the brain, producing sensations along the user's hand. By selecting different electrode pairs along a grid, different portions of the nerve are activated, producing varied sensations along the hand. In addition, by varying the stimulation level, the perceived sensation intensity changes as a result. Using sensors placed on the prosthetic hand, recorded force and joint angle information can be used to vary the sensory feedback delivered. In this video, a prosthetic hand user is identifying objects of various size and stiffnesses using solely the feedback provided. In doing so, the loop becomes closed, providing all three mechanisms involved in successful hand function. Thank you so much for your time and attention. We hope you enjoyed this short video and invite you to check out the BME repository for more exciting content.